For this week's interactive advanced concept assignment, we had the opportunity to make kinetic sand. Polymers are found literally everywhere on the planet. They have an extremely large amount of application. For this experiment, we made a polymer that has been getting a lot of attention on social media. In order to make kinetic sand, I mixed sand that I got outside from our sand volleyball court and allowed it to dry out overnight, and added 3 tablespoons of cornstarch. In a separate bowl, I mixed about a cup of water and a few drops of dish soap. I then slowly incorporated the water and soap solution into the sand and cornstarch mixture, mixing between every addition of the water and soap solution. Here is the result. Non-Newtonian fluids do not fit into the physical definition of solids or liquids. Instead of following Newton's law of viscosity, which measures a fluid's ability to defy deformation by external stressors, this substance exists somewhere in between. If you exert extreme force on it in a single motion, such as a punch, it will likely behave like a solid and not permit passage. However, if you exert force gradually by slowly adding pressure, the atoms allow your hand to pass through. This is a polymer solution, with atoms moving past one another in a reaction in the applied pressure. But what gives kinetic sands its transfixing effects? So, kinetic sand is a regular sand that has been coated with a silicone oil, or in our case, dish soap. Silicon doesn't refer to one specific material, but rather a group of materials that contain the elements of silicon and oxygen. Silicons are polymers, meaning they're molecules made up of long chains of repeated units. The compounds are used in all sorts of products, from cosmetics, lotions, shampoos, and conditioners to lubricants and sealants. Silicone oils have a unique property in that they can be liquids that flow freely or semi-solids that flow freely in the absence of pressure, but act like rubbery substances under stress. This characteristic is known as viscoelasticity. But a substance's degree of viscoelasticity depends on the length of the polymer change in silicone oil. For example, imagine long strings of spaghetti. They stick together so they can hold a shape, but if you place a ball of them on the counter, over time they slowly sink down into a low pile. Longer strings of spaghetti hold their shape better than shorter ones. Similarly, with kinetic sand, the polymer chains with the silicone oil make the sand particles stick together so that you can form them into a ball. However, the ball will slowly flatten out over time, but the silicone oil coated sand particles stick together or stick only to each other and not to other surfaces. This is why kinetic sand does not seem sticky and is an easy cleanup. So after doing this experiment and letting it sit out overnight, it was interesting to see how the sand substance actually did change. So as you saw in the video, I was able to form a ball and the ball held its shape. However, the next day the sand was more wet, and the ability of the sand to hold its shape was less likely, just with it sitting out over time. I did going back looking at this experiment, I think that I would have had a better result, and the sand would have better held its shape if I would have allowed the sand to maybe dry out for 2 days, or would have baked the sand in order to dry it completely out. Just with the weather around where I'm from, it has been wetter, and so the sand was not completely dry, and I think this might have had some effect on the ability for my sand to properly act in this experiment. Thank you.